Hello everybody, I'm Kellen Freeman from the Delaware County District Library's Maker Annex, and tonight we'll be looking at vector design basics. So what we're going to be doing is looking at how to create designs specifically to be used with laser cutting. We're not going to be doing a very deep dive into the software itself, more so the general concept of how to create these images in the software. I'll be using Affinity Designer. It is a vector design program, but it's not the only one. It's just one that I personally like to use the most. Common other versions are Adobe Illustrator. That's kind of the big industry standard one, but it's also the most expensive. Inkscape is available for free. It's an open source program. So if this is something that you're interested in getting a hand with, getting started with, you can go to inkscape.org and try that one. Affinity Designer, which I'm using tonight, is a paid program. It's not too much compared to Adobe Illustrator, and it does have a free trial you can give if you want to try that. But otherwise, feel free to watch along tonight or watch this later on. It will be recorded and on our YouTube channel, so you can watch it later if you want to refresh yourself on anything. The link on the screen has a handout that you can download. It will go over everything that will be going over tonight, and it will get you started as a refresher with everything that I will be covering. I want to point out that there is a delay between what I'm saying and what I see in the chat. So if you have any questions, feel free to leave a question in the chat, and I'll get to it when I see it. But there is a slight delay, so you may not have an immediate response with it. So just a little bit about what are vectors. So there are two types of images. One's called a raster image and the other is a vector image. Raster image is what you're probably the most familiar with. It is made of pixels. It's commonly found on cameras and computer monitors and any kind of still image that is made up of an assortment of pixels. These are great because they can have a lot of detail to them, but they are limited on size. Anytime you try and make it bigger than it originally was, the computer will have to guess as to what color pixels should go in the way, and you end up with what's called pixelation. Here's an example. So the one on the left is a raster image, so the S is, when it's made big, gets all those little artifacts around it, and it can be harder to see. A vector image, on the other hand, is built from math. So in the case of this S, you would perhaps have 2 points, one on either end, and mathematical curve in the middle saying, a line this long with this angle and this thickness. And when you scale it up, it keeps all of that and keeps it proportional to where it is, so that as it scales up, it still remembers where those 2 points are, what kind of line goes between it, and how the math goes with that. So they're great for this kind of work, but they're not always great for holding tons of information. Most often you'll see vectors used for logos in companies, but not particularly for photorealistic images. For our purposes, they're really handy to have for laser cutting and by extension vinyl cutting as well, but that's not really what we're going to be covering tonight. The reason for this is they have a sharp, crisp edge, and no matter how big or small you make them, they're going to keep that crisp edge. We've engraved pictures before that get resized, and then they get the same pixelation that you see on that picture comes out on the engraving, and it doesn't have as high quality as it could. So by keeping with a vector image, we're able to keep a nice crisp image that comes out very well. So to give an example, this is a picture of our laser cutter. It is an Epilogue Zing laser cutter. It has a working area of 1 foot by 2 foot, so you can engrave anything that big. It can engrave on objects up to 7 inches thick. So if you had a box or something, as long as it's less than 7 inches, we can fit it in the machine. And it can cut through certain materials up to about an eighth to a quarter of an inch, depending on the material type. To give an example of what that looks like, this is a video that we did the other day. It's running at 8 times speed, so it's not quite this fast, but it's still a pretty quick machine. This project only took about 3.5 minutes. And what it does is it goes through and it engraves everything on the image that you sent, and then it will go through and it will cut the shape out if you've defined a cut line. You don't have to define a cut line, and we're going to look at 2 different ways that you can create the same kind of end goal product with the laser cutter, but in kind of two different ways. And then just to give an example, this is that same piece that we just engraved. You can see the fine small letters on there and dotted lines, so it can do really high quality images as well, or detail. It can do images. This is a small plate of aluminum that we got as a sample from the company that makes the laser, and it can do things as sturdy as glass. It's kind of hard to get a good shot of the engraving, but it can do that, and it can do things as delicate as paper. So we were making holiday cards last December on the laser, and it can do a wide range of options out there. I will just say up front, it cannot cut through glass or metal. It can only engrave them. And if you have any questions about that, feel free to email us at makerannex@delawarelibrary.org about what the capabilities of each kind of material are for the laser. So let's hop into Affinity Designer. So this is, as I said, a vector program, and it's the one that I use the most, so I'm most comfortable teaching it. But a lot of these things that we're going to be covering tonight are available in every program. You just might have to look somewhere slightly different for it, depending on which program you're using. So to begin, I want to point out one key thing with how shapes and objects work here, and that is with color and stroke. So if I look at this little sidebar on my window, I'm going to see this color wheel and these two symbols here. The complete circle is the color of the object. So in this case, I've got a square, and it is a very light gray. On the other hand, there's this ring, this little kind of donut shape, and that has a black one, and that is the outline or the stroke. The stroke is exactly what it sounds like, or the outline functions exactly that as it is. It is the outline of the object, and if I increase the size of this, you can see what I'm talking about. If I were to change the color of the stroke to blue and the color of the body to red, you'll see how that works, and there's a whole variety of things you can make the stroke. A dotted line. If you want to do that, you can do different thicknesses. You can put arrow points on them. Regardless of how it is or what you choose to do, the stroke is the exterior object, or the exterior outline of your object. And then the color is the interior. We have found that black and white works the best for this. Occasional grays might work as well. But color does not come through the way you think it would. So if I wanted to engrave this object on something, believe it or not, it's going to largely come out the same color. We have this sample that we created that just gives you an overview of a grayscale from black to white, as well as the 6 main basic colors. And you can see that red and blue are largely the same, white and yellow are largely the same. Green and orange are pretty much the same. And so if you bring in a full color image, it may not come out the way you think it will. It's not quite like printing on a color printer. It's more printing on grayscale. So if you can, always try and work with black and white, maybe a couple grays. Depending on the material that you're using, those grays may or may not come out. But generally, black will come out perfect, and white will just not exist on the object. So what I want to work with now is creating a coaster. We're going to be making a coaster for a homebrew pie company that we're working on. We offer coasters here. We have them, they sell for, I believe, $1.30. You can check on our website. I forget exactly what the pricing is, but they're just 3 and 3/4 inch bamboo coasters. They're pretty decent. I like them a lot, and we're going to create one on that. So there's two kinds of materials that you can work with. There's either flat stock, which is just taking a flat sheet of material. This is some MDF scrap that we have laying around. In this case, you would most likely cut an object out of it. So we could make a circle cut line. We could cut the whole object out of the flat stock. Or there is working on a specific sized material, like the coaster, or maybe a photo frame or something that you're engraving onto versus cutting out of. In this case, because we're engraving onto something and we know the size of it, I'm going to change the size of my document. So I want this to be 3 3/4, because that is the diameter of the coaster that I'm working with. This is not explicitly a required step, but I'm going to do it anyway, just because it helps me to visualize things. I'm going to make a circle the size of my coaster. So because I have a round coaster, I'm just going to put a circle on there, and then I know that anything that I put within this circle will fit within the coaster itself. When I'm done, I can delete the circle out so that it doesn't engrave or affect the overall image, but it just is there to help remind me where I'm working with. So I have found an SVG image of a pie that I want to use with this. SVG stands for Scalable Vector Graphic, and it is a great option for it's one of a couple different vector types. It's really good, and it's the most common one that you'll find as well. So I have this pie image, and I'm going to center it on my object and make it a little bit bigger. So I can hold a couple buttons. So by holding Control, I can grab it and it will scale in all directions so that I don't have to reposition it. It scales from the center outwards. And then we're going to need some text. So there's a couple kinds of ways that you can do it. So you can just type. You can just type into a box. That might be fine. The other option is to type onto a curve. So that's what I would like to do. So I'm going to put another circle inside here. And just to make sure I can see it, I'm going to reset my stroke back to something that's a little helpful to see. And I'm going to put this circle centered as well. Now when I take the text tool, I can hover over top of my selected circle, and you can see the A that's there would be a starting point for a text, but if I hover over the line, it becomes a little T with a little wavy line. That means I can then start typing on this line. So now that I do that, I'm going to type in the name of our pretend pie company, and I'm going to change it up a little bit. I want to make the font a little bit bigger. I'm going to change it to something a little more fun. Go with this one. And this is something you can play with as well. I'm going to change where the end point is on these just so that I can make things look a little bit fancier. And I'll adjust the baseline just so things kind of sit a little bit more evenly. So now that I have my text on here, I have my image, that is really all we have to do to make the coaster. We've got all of the parts. I have, once again, a black image. All of the parts are black, which means they're going to engrave incredibly well. You're going to get a nice deep engraving with it. And I'm going to remove this background so that it doesn't go, because that gray will engrave. Anything that isn't white will engrave. It will just engrave to a different extent. And then, so when we send this in, which we'll cover how to do that here in a little bit, and it goes onto the laser, we'll end up with a coaster that looks something like this. I don't know if you can see, it's a pretty nice engraving. It goes into the surface itself. You can see it from a distance, and it works really nicely. And so that's working with a piece of established material, so a coaster. Say I wanted to cut this out of flat stock. In that case, we need to define a cut line. Defining a cut line is pretty simple. In this case, I still want a round coaster, so I'm going to do that. And because every program is slightly different, and when we import it into the software we use to cut, it may not come through exactly the same, we ask a couple things. So the first one is that we're going to define our cut line as a red line. This will make sure that when we get the file, we know that this is something you intend to cut versus something you intend to engrave. And then for Affinity Designer, we're going to go with point to point. Other programs use their sizes in inches or something, and every program seems to be slightly different. But for this one, we're going to go with a point to point size. And you can see how thin this line is. That means when at this size, anything 0.2 point or smaller, so like a 0.1, will cut through the material. Anything over that is going to engrave. And so when it comes through, we're going to get that. And then when we take our MDF sheet with it, or it could be acrylic or plywood or cardboard, whatever it is you want to engrave it on, we can cut out that same shape. And so you can see the burnt edge on this came because the laser went through and burnt the material away in a fine line, and you end up with an MDF coaster. That's a real quick and simple overview of how to do that. A lot of tools within these programs work pretty similarly, as I said. And one of the nice things is you can make custom shapes. So say I wanted this pie icon as a necklace pendant. I can customize that. I can make a circle here. And then I'm going to make another circle around it so that I can enclose that piece of pie that's sticking out into it. Now the downfall of this is that shape is going to not quite fit right. Because the pie sticks out, it can be a little tricky. So I'm going to be trying to fill in here a shape that we can cut out. So now that I've got this extra little pie piece here, I'm going to try and cut out the shape, and that went the wrong way. So I want to point out over here, we have these layers. Layers work just as if you had individual pieces stacked up on top of each other. So if I have a bunch of pieces of paper stacked over top of each other, I can adjust those however I want. I can put one of them on top, one of them on the bottom. Anytime that you go to cut, you're going to cut the top shape out of the bottom shape. So for me, I want to move this triangle down. And it still didn't quite end up with what I wanted. Okay. This is me thinking, okay. So I just chose a different option there. I chose the intersection tool instead of the subtraction. and that gave me this little pie piece shape. I'm now going to merge these together into one shape, and now I have this custom shape. This is not something you can get from many of the tools on the side, but you can make it by taking a few pieces and sticking them together. And now I'm going to just take a small little donut shape and merge that in with this as well. And now we have a pie pendant that we could engrave. I didn't plan for this one, so I don't have an example of this one to show you. But when we go to send this to, say, the plywood or the acrylic or something, it will go through and it will engrave the pie image on it, just like you would see here. We get that same pie level or engraving level, and then it will go through and it will cut this thin red line out, and that will then give you a custom shaped little pendant. We have, for example, these earrings that were cut in the similar way. So it was just combining a variety of shapes, texturing different thicknesses of objects together, and then cutting them out of each other to create a custom shape that can then be cut out. So once you have completed that and you have your object ready to go, you have it just how you like it, and you're ready to send it to us, there's a couple things you need to do. We ask that you send it to us as an EPS file. That stands for Encapsulated PostScript. And what we found is that while SVGs are very common, SVGs can be slightly goofy between programs, and we've had better luck with people sending EPS files instead. So if you send us an EPS, we'll be able to get it to you, or get it to our laser working really well. Sometimes you go to save as. In the case of Affinity Designer, we're going to go to export, and I'm going to choose the EPS option and export that. That will give me the option to save it to, I'm just going to save it to the desktop. And we'll save it as the pie pendant. So now that I have my pendant created and exported as an EPS, we're going to send it in through our submission form. So if we go to DelawareLibrary.org, the library's website, you can scroll down on the home page to the Maker Annex location. We're here at the bottom of the location list, and select the button which will take you to our page. It's being a little slow because I'm live streaming at the moment, but now the computer seems to be hiccuping. Okay, so we are from the Maker Annex page. You can scroll down to the Submit a Project option. Clicking that will take you to our wiki site, which has our project submission page. And this is a simple form that we ask you fill out to send in projects. It has a few questions, but that just ensures that we know who we're getting the project to and how to and what the project is. So we'll ask for your name. We'll ask for your library card number. When we finish your project, we put it on hold for you, so you'll get notified that it's ready exactly the same way as if you were to reserving a book or a DVD. And we ask for your email, mostly because if we have any questions about your project, we can use that as a way to get a hold of you and clarify things as needed. We have pickup locations for each of our branches. Right now, we're located in the Delaware library in the back half of the computer room. And so anything that's requested to pick up at Delaware will be ready pretty quickly. If you want to pick up at another branch, we will send it to you, but our deliveries are slightly delayed right now, so it may take a little bit longer to get to you, but we will still send it to whichever branch you want to pick up at. In the case of this, we're going to select what type of project we're doing. In this case, it would be a laser cutter project. We'll select a material for this. I'm going to choose our plywood, and then I can upload our file, the EPS file. You can submit up to 5 files per submission, so if you have multiple pieces that you want cut out or worked on, you can send those in without having to send the form each time. And then there's a notes field at the bottom. That notes field is just if you have any comments for us, just things we need to know. Perhaps in this case you would like one made on plywood and also one made on acrylic. You don't have to send the form in twice, just leave a note in there requesting a second version be made with acrylic. As long as they're the same file and we're not changing anything, we can work with that. Sometimes people will send a file in and request 5 copies of it. Something like that. So the notes field is optional. If you don't have anything to share, you don't need to. It just allows us to get a little bit more of an idea of what your project is about. So that is the very basics of vector design. As I said at the beginning, if you have any questions, feel free to email makerannex@delawarelibrary.org. We're happy to answer questions and work with you. Right now, the Maker Annex is closed for visitation from patrons, but we're happy to work with you and answer questions over the phone or over email. And we hope to see you soon when patrons can begin visiting the Annex once again. As I said, any questions, makerannex@delawarelibrary.org, and hope to see you soon. Thanks.